Okay, class, we're moving on to chapter 9.5, graphing functions. This is where we're going to put it kind of all together with what we've just been doing in the last couple lessons with the first two lessons from the chapter. And we are going to be using what we call a quadrant grid, which is down here in the lower right-hand corner. It's going to look very much like the first graphs that we did. The input value is the x. That is going to be graphed on the horizontal axis. Now, your graphs don't have it, but you can see down here in the video that there is a small x. So if you want to put an x down here on the horizontal to help you, that would probably be a good idea. You can also see on the vertical there is a y. You don't have it on your graph. Again, I've had to kind of redo lessons from transparencies. So maybe put a y up there until you really have it memorized that you have to go with an x on horizontal and a y on vertical. Now, the input 0 tells us that we want to be right here where our x is 0. The output value of 3 for y means we want to start at 0, go 1, 2, 3, and make a dot. For our value of 1, input of 1, we're going to get a 5. So we're going to go horizontally over to 1, up to 5, and make a dot where those two lines kind of crisscross. It's called the intersection. Then we're going to go to 2 and go up to 7. So over to 2, up to 7, and make a dot. And then we're going to go for 3, 9, which means we're going to go over to 3 and up to 9. Now this is where it's a good idea for you folks to have a ruler. I can't use one on the smartboard because it'll confuse the smartboard. So I'll do my best to draw it as straight as I can freehanded. But you're going to line it up with your ruler, and you're going to go all the way through that quadrant, and notice you're going to have a single-headed arrow. We're going to find in a later lesson that there's 3 more quadrants to deal with, but we're in this lesson just going to deal with quadrant 1. What it indicates is that the values keep on going upwards past where y is 10. Let's look at our next example. It says you try this one. So hit pause, put in your dots, get your ruler, then you can check it against mine later. Okay, folks, how'd you do? A little tricky, huh? Because it gave you a 0, 5. This is where we have to practice that, okay, if the one line's 4 and the next line is 6, the 5 has to be in between them. So sometimes instead of drawing your dots on the intersections, you'll be drawing them partway up the block. But that's what the function graph should look like. Let's move on. Here we go, folks. This is a 4-quadrant grid. It is also called a Cartesian coordinate grid, named after a mathematician named René Descartes, who was a French mathematician. The truth is there are times when inputs and outputs can be negative numbers. And in order to do that, we have got to have a 4-quadrant grid. This is quadrant 1. And you'll notice that x's here are all positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you'll notice that they only put in the even numbers. You'll also notice that all of our y's in quadrant 1 are also positive numbers. 2, 4, 6, 8, 10. Those are all positive. Now we go counterclockwise. This is quadrant 2. And here, x is negative. Do you catch that? Negative 2, negative 4, negative 6, negative 8, negative 10. But your y values are still going to be positive. 2, 4, 6, 8, 10. Continuing on, this is quadrant 3. And if you'll notice in quadrant 3, x's are negative numbers, and so are y's. Because we're going to have negative 2, negative 4, negative 6, negative 8, negative 10 going to our left, and we're going to have negative 2, negative 4, negative 6, negative 8, negative 10 going down. Now, if you haven't kind of caught on, positive values are always either right or up. Negative values are either left or down. This quadrant is -4. We have positive x's, and then we have negative y's. So we're going to move right, and then we're going to go down on our y. Okay, so our first value here is -3, -1. We always kind of start at this midpoint right here, middle of the graph. It's called the origin. And the -3 says we're going to go to our left to -3. So we're going to go over to here. Now don't make too big a dot, just an itty bitty dot. Now we have a -1. That means we're going to go down to -1. Your graph has a line there. Mine doesn't, so I have to kind of guesstimate. It should be about halfway here. If you make a big enough dot, it'll cover. So that should be about -3, -1. Our next value is -1, 1. It's called an ordered pair, -1, 1. This is the ordered pair, -3, -1. An ordered pair is always written as xy. So I want to start at my 0, go to my left to -1, but this time y is 1, so that means it's up here. My next ordered pair is 0, 2. I'm going to stay at 0, I'm going to go up 2. My next ordered pair is 4, 6. I start at 0, go over to 4, over here. Now I got to go all the way up to 6 and make a dot. And then my last ordered pair is 7, 9. I start at 0, go all the way over to 7, which is here. And this time I'm going to follow that line all the way up to the 9 and make a dot. Now again, I am going to get my ruler. That would be your best bet, is to get your ruler and draw it in. I will do my best free-handed. And notice I don't make an itty-bitty line. I go through a whole grid. I want to make sure that I'm showing you that you can extend that line even to values that aren't shown on the Cartesian coordinate grid or on the coordinate grid or 4-quadrant grid. How about it? You want to try one for yourself? Here's example 4. It's a little trickier because they're going to get you to use the function. So maybe we better do it together. Okay. X is going to be -3. So -3 times -3 is 9. That means my ordered pair is -3. That doesn't look very good. I'll try that again. It's going to be -3, 9. 0 times -3 is 0. So I'm going to be right at the origin, which is 0, 0. -3 times x is 2. So -3 times 2 is -6. So my ordered pair is 2, -6. Remember, we go the x and then the y, and we make an ordered pair. -3 times 3 is -9. So my ordered pair is going to be 3, -9. Now I will need to graph those. -3, I'm going to start at that origin in the center. I'm going to go to my left to -3. Over here, you can kind of see where my little blue dot is. I'm going to go all the way up that line to 9 and make a bigger dot. Now I'm going to be at the origin, which means right at 0, 0, and I'll make a bigger dot there. 2, -6. Okay, I'm going to start at the origin, go over to 2, little small dot. Now I want to go down to -6 because it's negative. That means I go down to the -6. 3, -9, so I'm going to start at the origin, go over to 3, and go all the way down that line to -9. And this one is not going to be real easy for me to do freehand, but I will try. let's see. I'm going to have to plot another point in here just for myself so I can spot it. Okay. Yeah, my line's not too straight. Hopefully yours works out better. Okay, now if you'll notice, this line is slanted downward. That's called slope. If you're going to walk down, let me see if I can pull up an extra color to show it to you. Let me try red. If I can walk down the line, that's called negative slope. If I can walk up the line, that's positive slope. Positive slope, I can run up the line. Negative slope, I got to run down the line or slide on my bum down the line. So, positive slope, I can walk up or run up. Negative slope, I'm either going to walk down or slide down. And that concludes lesson 9.5. Catch you next time.